Hello everyone, welcome to the KANPUR-NPTEL online course on space environments and its effects on orbital spacecrafts. So, in the last session we discussed about different satellite orbits and its geometry, followed by how to calculate the velocity and the period. We discussed 6 orbital parameters and what are the orbital perturbations. So, to continue that discussion, today we will cover the different types of Earth's orbit which are used for satellite applications. So, we will consider the low Earth orbits, that is LEO, then medium Earth orbit MEO, then polar Earth orbit. We will define each of the orbit subsequently. Then sun synchronous orbit, high Earth orbit, and in high Earth orbit we will consider 2 types of orbits, that is geostationary Earth orbit and geosynchronous orbit, or it is called GSO. So, when you consider the man-made or the artificial satellite in Earth's orbit, so in most of the cases, in fact, whenever a satellite for some particular function it is or a operational satellite is launched, satellite is placed in its predetermined orbit, means the designated orbit. So, it again depends on what is the function that satellite will carry out. And so, we will see that the satellite it does a variety of functions and we classify the satellites accordingly, we classify those satellites. So, there can be some of the applications where the satellite is not there in the Earth's orbit. So, it can be in the orbit of the other planets or in the orbit of the sun itself. So, these are the different other, this is the application of the satellites. So, different based on the different functions we classify these satellites, like in the communication satellites, where the communication can be a point to point communication or it can be something like the broadcasting like the TV programs. The satellite application can be the navigations like the GPS or the Navig. So, the navigation means using a satellite you can know that is the location of a particular the object or particular person with who is having a navigational receiver. Then there is another important application of the satellite is the remote sensing of the planets. So, using the instruments on board the satellite you can know about the what is the atmosphere of the planet, what is the structure of the planet. So, all those things can be known or can be derived using the satellite based instruments. There can be the space exploration, what I mean to say that is this space research, knowing what are the other planets, what are the atmosphere of the other planets, or even going beyond the planets, what is happening there. So, all these things can be also done by space based instruments. So, we will discuss the different orbits for satellite applications. So, most of the satellites, so we will see that is they orbit in the low Earth orbit, whose altitudes, that is the height of the satellites, typically less than 2000 kilometers. So, when I am calling it 2000 kilometer, I mean to say that this is a circular orbit. Apart from this thing, there are the satellites this is the orbit which is called a geostationary orbit. We will come to we will discuss why it called as a geostationary orbit. So, there the altitude or the height of the satellite is around 36,000 kilometer. Precisely if you calculate it, it will come 35,000. So, there is one more 0 has come. So, let me. So, it is 35,786 kilometer. The other clouds of satellites, mainly the navigational satellites, they are in the range of altitudes from 2000 to 3,500-786 kilometers, called the medium Earth orbit. So, you can see in this table the different orbits, like it is showing that medium Earth orbit from 2000 to 35,786 kilometers, and one figure it is called the 20,350 kilometer, the semi synchronous orbit. I will define what we call a semi synchronous or a geosynchronous orbits. It depends on what is the period of the satellite to complete one orbit. So, the name of this navigational satellite is GPS, then there is the Chinese, there is the constellation of the navigational satellite is called the BIDAO, then the GLONASS, this is the Russian thing, then Galileo, this is the European satellite system for navigational satellites. Now, these are the now here we have that is the low earth orbit. So, the low earth orbit we are considering it 160 to 2000 kilometer. Of course, satellites, if you keep a satellite or if you put a satellite in 160 kilometer, it will be very unstable because of the atmospheric drag. So, generally the satellites are at least from 300 kilometers and above. So, you see in the 350 kilometers, the example of the satellite, it is the Shenzhou spaceship, there is the Chinese spaceships, then 400 kilometers is the international space stations, then 500 to 2000 kilometers that can be the communication satellites like this Starlink. There is one way, there are so many types of constellation of satellites. Then at 595 kilometers, there is the Hubble space telescope, which is used for the space research, that is the astronomy purposes. Then we are having 600 to 800 kilometers Indian remote sensing satellites. There are a number of satellites are there in this orbit. Then the 700 to 1700 kilometers, the polar orbiting satellites. Then coming to that is the high earth orbit satellites. There are two types of satellite, one is the geosynchronous orbit satellite and the other one is the geostationary satellites. So, they are generally communication navigation satellites are put. So, we are having our in Indian system that is called the Navik satellite. So, these are also put in the both the geostationary as well as the geosynchronous orbit. So, satellites are usually classified based on their orbital altitude, that is the distance from the earth surface, which directly affects the coverage and the speed which they travel around the planet. So, when we choose a particular type of orbit, that is the spacecraft developers has to consider that is what is the intended purpose. And so, based on the application, the satellite orbits are decided. And we will see that we need to consider what is the environment also, what is the risks, all these things we will see. So, based on this thing, there are basically 5 main types of satellites based in the orbits. So, that is the low earth orbit, already we discussed, medium earth orbit, geostationary orbit, sun synchronous orbits and the geostationary transport orbit. We will discuss each one by one. Now, for the orbit classifications, there are different ways you can do the orbit classification. We will discuss one by one. So, the classification based on the size. Size means what is the altitude, where the what is the height of the satellite in the orbit. So, this is the size, then what is the shape? Shape means it can be circular, it can be elliptical. Then the location means what is the inclination of the orbit with respect to the Earth's equatorial plane. Then the direction, whether it is a clockwise or a counterclockwise, what is the direction the satellite is orbiting. So, that also gives you the type of this orbits or the satellite. So, orbit classification if we do based on the size. So, we are having again whatever we decide, that is the 3 types of satellite, that is the low earth orbit, the medium earth orbit and the geostationary orbit, or we can say it is a HEO, that is high earth orbit, and geosynchronous orbit, that these two comes under this high earth orbit. So, we will now discuss the geostationary orbit. So, geostationary orbit has a that is the orbit period, that is the time taken by the satellite to complete one orbit, that the revolution in one revolution, that is 24 hours, and the orbit inclination is 0, means this orbit is in the equatorial plane of the earth. So, in this orbit what happens, the spacecraft appears to be fixed over a specific location on the earth's equator. So, this is because the satellite, the movement of the satellite, that is the speed of the satellite and the earth's rotation, that is the speed of the earth rotation, they are the same. So, the one body is the relative velocity between these two, that is the relative velocity is 0. So, that is why it seems that the satellite is stationary with respect to a point on the earth. So, you can see when the satellite is revolving around in this orbit, a geostationary orbit, the point where the satellite, if you the sub satellite point, that is as if it is constant with respect to the satellite. So, we can calculate at what altitude the satellite should be positioned so that it is the geostationary. So, already we said the period of the satellite should be 24 hours. So, we can calculate A from there by using this equation and using this mu that all those the constant figure we know. So, we can calculate H is equal to this is the figure. So, if we place a satellite in this orbit, in a circular orbit in the equatorial plane. So, this satellite, the satellite will seem as if it is constant, it is not moving with respect to a point on the earth. Okay. Now, let us see what are the advantages of the geostationary satellite. So, the as I said, it is the satellite is always visible, it is the visibility is continuous, and since it is in a very high altitude. So, it can cover the wider area. So, as the satellite will be closer and closer to the earth, so is that coverage area will be reduced, because what is happening, the angle, that is whatever, if you consider a particular angle, suppose you consider an angle theta. So, what is happening, say this the area coverage will be given by r theta. So, whenever this r is changing, so means your the area of coverage will increase. Then you basically you do not need the ground station tracking to track the satellite, because it seems to be stationary, but in practice there can be perturbations. So, whatever the tracking is needed, that is very simplified, and whenever you do the communication. So, like the satellite is in communication with the the earth station. So, we do not need any handoff, means one satellite to that other satellite, that is called the handoff, that is not needed for the continuous communication. And whenever we put the satellites in a geostationary orbit, that is at 35,786 kilometers, fewer satellites, in fact, it can be shown that only 3 satellites will cover the whole globe. And here you are having the minimum Doppler shift. Doppler shift means whenever you transmit a radio signal, if one body is moving with respect to the other, there will be a frequency shift. But in this case, since it is virtually the satellite is stationary, so you will not have any Doppler shift. What are the disadvantages? The first disadvantage is the significant signal delay, because if you consider this because there is always a wireless communication with the satellite. So, the signal has to travel a larger distance. Okay. So, if I consider the velocity is there is the velocity of light c or velocity of the there is a radio signal or the is c, then we can show that the time taken by that will be by your that whatever the satellite altitude is there, that is r by c. So, in that case we can show that when the r is high, so r is the satellite altitude, and c is the velocity, is the of the RF signal. Okay. So, this is the disadvantage, that is the significant signal delay. Then since it is an equatorial orbit, so when you go at higher latitudes you are going away from the equatorial plane, there will be the coverage will be poorer, and here there is a weak signal strength. So, whatever the signal is sent by the satellite or whatever the signal is sent by the ground station, the signal will have a that is the path attenuation. This is called the spreading loss. Spreading loss. So, it is a function of 1 by r square. So, whenever the r is higher, the higher and higher will be the signal loss. So, you are having a weak signal strength, and it this launch and when the satellite building, it involves the higher costs. So, the next type of satellite, it is called the geosynchronous orbit or GSO. So, GSO again the its the orbital period is the same, but only difference here is that it is not in the equatorial plane. So, it can have an inclination angle. So, a particular case is the geostationary, when the inclination is 0. So, it is the that orbit you can call it a geostationary orbit, when the inclination of the geosynchronous orbit is is 0. So, in this case what will happen, if you consider the sub satellite path. So, after this satellite completes one orbit, it will come to the same point and it will look like a figure of 8. So, this is the, so here instead of it say there it was not, the 2 points were the same. So, what is needed here in a geosynchronous orbit? So, the ground station should track the satellite over this, so that you are always connected to the satellite. Okay, so, this already I said, that is it is a special case, is a geostation in orbit. And this type of geosynchronous satellites are used in communications and the navigations, and also for the communications where for the higher the countries of having the higher latitudes like the Russia. Now, let us come to that is low Earth orbit. So, low Earth orbit is typically the satellite is placed between 300 to 2000 kilometer, and here the since the satellite is a lower altitude. So, it is the field of view, that is the it will be having it will less because the altitude is lesser. So, obviously, this its field of view will be or the area of coverage will be smaller. So, here if I want to have a have the communications and I want to have, that is the cover I want to have this a global coverage. So, here the number of satellites will be more number of satellites, and a number of satellites will be required to do that. And here suppose if you can calculate using those formulas. Suppose if I use a 1000 kilometer satellite orbit. So, this is orbital period will be orbital velocity will be 7.3 kilometer, and you can show the orbital period, it will be something like 150 hour 50 minutes. So, and the visibility of the satellite means having using a earth station, we can see the satellite depending on its what is the orbit height. So, lesser the orbital height, this visibility means we can connect with the satellite or get the signal from the satellite, that will be lesser and lesser. So, it can be, suppose if I consider a 300 kilometers orbit. So, I can see the satellite only for 10 minutes. What are the typical applications can be used for the communication like this Starlink, or then the earth observations and monitoring and various scientific explorations. So, this low Earth orbit is also used for the space laboratory. So, like the international space stations, or what is planned our Indian space agency ISRO is planning for the Bharatiya space stations. So, these are placed generally in the low Earth orbit. What are the advantages of the low Earth orbit satellite? So, because of the low altitude, the communication signals the loss of the signal or the path loss is since it is lower. So, the signals do not require a lot of the transmitted power, and the time needed for the signal to travel to and fro, that is from the satellite to the earth station, is less. So, this is also called the latency. So, you get a the better latency, and we have a better resolution. That is when the imaging satellites captures better or more detailed pictures. And this low Earth orbit satellites are very easy to build, and their cost is also less as compared to the higher altitude satellite. What are the disadvantages? Disadvantages is that because the low Earth orbit is getting populated very highly. So, this can result into this lot of the space pollution or the debris when the satellite is not operational or there is some damage in the satellite. So, this will become a debris, and there is in the low Earth orbit this perturbation due to atmospheric drag is higher and higher. It is having the field of view, FOV means the field of view, this is the small, and means it is having a smaller coverage. Now, let us come to the next is medium Earth orbit. So, medium Earth orbit again it comes in between the geosynchronous or geostationary orbit and the low Earth orbit. So, its advantage and disadvantage will be just in between these two orbits. Okay. So, most of the satellites they cover between these two distances already I told, and again this medium Earth orbit satellites this includes both the zones, that is the Van Allen belt radiation belt, that already we discussed those things. So, there is then when the satellite is there in the Van Allen or in the radiation belt, there is a chance that the satellite can get damaged because of the high radiation dose. And this medium earth orbit, mainly it is used for the navigation satellite, the global positioning systems, and this provides coverage over larger areas than the LEO satellite, because its altitude is higher, like the GPS satellite are kept at something like 20,000 kilometers. So, their coverage will be much higher than that of the LEO satellites. What are the advantages? The advantages, again it is this advantage we will consider with respect to the LEO satellites. So, here as compared to the low earth orbit satellites, here that is the fewer satellites are needed to cover the entire surface of the earth, and MEO satellites are launched at a lower altitude as compared to the geo satellites. So, consequently the time delay or the latency is better here as compared to the geosynchronous or geostationary satellites, and it requires slightly higher transmit power as compared to the LEO satellites, but of course, it is an advantage as compared to the geostationary satellites. And this overall system cost is definitely cheaper than the geosynchronous or geostationary satellites. And disadvantage, again here we will compare it with that of LEO. Here the signal, the loss or this attenuation will be more as compared to the LEO satellite. And a single MEO satellite is visible only to 2 to 8 hours from a particular point on the earth. So, this is a disadvantage as compared to that of a high earth orbit satellite, and this system is more expensive as compared to a low earth orbit satellite. So, what is needed? A constellation of satellites or multiple satellites are needed when a continuous service is to be provided. Now, when we consider this is based on the altitude, now the orbit classification based on the shape. So, there are we will consider two shapes, that is the circular and the orbital orbit or highly elliptical orbit. So, this shows the different types of the orbit. So, this is based on the shape. There is one more type of satellite orbit. So, this is generally the elliptical orbit, highly elliptical orbits. This type of orbits are used. So, you can see this is called the geostationary transfer orbit. So, satellite is not directly put to this 36,000 kilometer orbit. Instead, that it is put in a very highly elliptical orbit, and then using this onboard the that is the propulsion system, it is finally maneuvered to the geostationary or the geosynchronous orbit. Even when we send the satellites to the other planets, so the techniques there is a transfer. So, here you see this is the orbit shows from the satellite is injected in the Earth's orbit, and finally, it has been put to the lunar orbit. So, this is called a lunar transfer trajectory orbit. So, based on the the location, that is the inclination angle, whenever you are putting this satellite on the equatorial orbit or in the inclined orbit or in the polar orbit. So, it shows like that. Polar orbit means the orbit is passing through the pole or by nearby that. And there is other classifications that is called the sense of the direction. This is the prograde. So, prograde means in which the satellite moves in the same direction that of the Earth's rotation. And so, the angle will be between 0 to 90 degree. The other type is called the retrograde, where the angle is between 90 to 180 degree, and you can see these are the two types of the orbit. The last type of orbit I like to discuss is called the sun synchronous orbit. So, in the sun synchronous orbit, the line that is the sun illumination, the satellite is put in such an orbit in which the satellite it is in synchronous with that of the that is the sun and the earth line. So, that gives you an advantage that the satellite crosses a particular area, it is the same local time. So, this gives a lot of advantage, and it is useful for various that is the remote sensing applications. And so, this is especially for earth observation satellites or it is called the remote sensing satellites, sun synchronous orbits are used. Now, a quick summary. In this session, we just discussed different satellites based on the orbit, based on its orbit, whether it is a low earth orbit or a medium or earth orbit or a high earth orbit. Okay. And then we discuss the advantage and the disadvantages of each advantage and disadvantages of each type of satellite. So, with this I am concluding here. Thank you very much.